Hi, boys and girls. Welcome back. Today is Tuesday. We're meeting together on Tuesday today because yesterday was a holiday. I hope you had a nice long weekend. So today, believe it or not, we are starting week 7, lesson 13 in our distance learning. And we're going to continue talking about matter and properties of matter. And what we're going to talk about today, boys and girls, is absorption, or which materials will absorb liquid. Okay, before we do that, I want you to get a piece of paper and a pencil, and then I'm going to ask you to write these down. I'm going to ask you to write the word paper, foil, cotton cloth, and paper towel, and try to set your chart up like this. Okay, please pause this video and do that now. Okay, thanks for doing that. All right, so like I said, today we're going to take a look at which materials absorb liquid. And in this case, we're going to use water as our liquid, although there are other liquids. So we did say absorption is a property of matter. And let's talk about our focus, our objective, which is I will make predictions and draw evidence-based conclusions about which materials absorb the most water. And that just means that we're going to do an investigation and we're going to actually prove which of our materials that we're using absorbs the most water. Before we do that, I want you to make a prediction, okay? So we're going to work with paper, foil, you might call it aluminum foil, cotton cloth, and a paper towel. So what I want you to do is to think about these materials and the properties of these materials, and I want you to just make a prediction, and you can just put a star next to the word for your prediction, the one that you think is going to absorb the most water. Okay, pause this video and do that now. Okay, boys and girls, so we talked about absorb. I want to show you something. So you remember a graduated cylinder, we used this in a previous lesson. Okay, so this shows 50 milliliters of water, and this is just water from the sink, plain tap water. I'm going to pour it into my container, and I've already marked, there's a black mark that shows the level, the water level. I'm going to take a sponge, and think about what you know about a sponge. I'm going to drop it in to my container, and we're going to see what happens. This is kind of like just testing your knowledge of what it means to absorb. So I can move it around a little bit. I can even pour out a little bit of the liquid, but not all of it comes out. So if I take out the sponge, I'm going to gently take out the sponge, we're going to see, did it absorb water and how much? I'm going to put this in here. Okay, so if you can see, the water level used to be at the black line, and now it is not. It's no longer at the black line. So if I want to measure, I can pour it back in and see how much it actually absorbs. So now we went from 50 milliliters, we're down to about 20 milliliters of water. So it's absorbed about 30 milliliters of water. And that's what we're going to do with other materials today, boys and girls. Okay, so before we get started, I want to explain to you that in order to have a fair test, we're going to investigate, but everything has to be fair, meaning everything has to be the same except one thing. So we have the same amount of liquid. We have 50 milliliters of liquid in the same kind of glass. We are going to time each material for 30 seconds. We're going to put the material in the water and let it absorb for 30 seconds. And then the materials themselves are the same size. So the only thing different is the actual material itself, and that makes it a fair test. So what we're going to do first is we're going to start with our paper, and I have my timer here. We're going to time for 30 seconds. All right, so I have 30 seconds on the clock. I'm going to put my paper inside of my glass and start, okay? And you'll hear it when it goes off. All right, so we'll see what happens. Okay, so for 30 seconds, we'll see what's happening. Does it look like it's absorbing? I can even turn it around so you can see a little bit better. Think about What's happening with it? Okay, we're going to stop. I'm going to pull it out. All right, I'm going to put this over here. And then I'm going to pour. And so boys and girls, we started out with 50 milliliters of water. I'm going to pour the water that's left over back. I'm going to pour it into my graduated cylinder, and then I'm going to see how much is left. So it was 50 milliliters. I see there's 49 milliliters of water that's left. So that means that if I have 50 and I subtract 49 milliliters of water, because that's what I have left, I have 1 milliliter of water left. So that means that 1 milliliter of water that was absorbed. All right, so 50 minus 49 is 1. And remember how you do this. All right, you have to make a... Okay, so 1 milliliter. All right, now I'm going to pour this water into my bowl, and then we're going to try our next material. Well, actually, my paper mill, I'm going to say it was 1 milliliter. All right, now we're going to try our foil. So again, 50 milliliters. I'm going to press start on my timer, and we're going to start to absorb. See how much this absorbs, the foil. Think about, do you think it's going to absorb more? Is it going to absorb less? It all started with 50 milliliters. And we'll just leave it, and it's a fair test, so we're going to time it the same amount. And we have a few more seconds. Okay. All right, now I'm going to take it out. I'm going to take it out and put that over here and pour the water back into the graduated cylinder. We started out with 50 milliliters, and we still have 50 milliliters left, so that we can say that the foil did not absorb. It absorbed nothing. So we'll say that the foil absorbed 0 milliliters. Okay, so far the paper is more absorbent than the foil. All right, let's go to our next material, which is the cotton cloth. All right, I'm going to turn it this way, and we're going to start. Remember, we started out with 50 milliliters, and I'm going to start my clock. Okay. Let's see. Think about what is going to happen. I think it's going to be more or less. Okay, I'm going to pull this out, put this over here, do it again. I'm going to pour my water back into my graduated cylinder and see how much is left. And if I see how much is, so I started, oh, look at this, boys and girls. So I started with 50 milliliters, and now there's 30 milliliters left. So if there's 30 milliliters left in the container, that means that the material absorbed 20 milliliters. So I'm going to say there's 30 milliliters left, so 20 milliliters was absorbed. All right, then we're going to record that. Oops, 20 milliliters. Okay, just ignore that. All right, and our last material is the paper towel. Same thing, same 30 seconds. We're going to put 30 seconds on the clock, and this is the paper towel, same amount of liquid, and we're going to start the clock and see how much the paper towel absorbs. All right, and let's begin. We have about 10 seconds left. You can be thinking about which one is going to absorb the most. So far, it looks like the cotton cloth has definitely absorbed the most. Okay, all right, take this out. What do we do next? We have to see how much is left, and that will tell us how much was absorbed. We're subtracting the amount that's left from the amount we started with. So, oh, look at this. So it looks like there's about 37 milliliters of water left. So 37 milliliters. So we subtract, we started out with 50. We're going to subtract 37 milliliters. So how much are we going to have left? Okay. We're going to have 4 minus 3 is 1. We're going to have 13 milliliters was absorbed. So boys and girls, what do you see? Paper, the paper, 1 milliliter of water was absorbed. The foil, 0 milliliters of water. The cotton cloth, 20 milliliters. And the paper towel, 13 milliliters of water was absorbed. Okay, so what can that tell us? What conclusion can we draw from that? We can draw that if you were looking for something to absorb, you wouldn't choose paper. You wouldn't choose foil. You might choose the paper towel, but it looks like the one that absorbed the most is the cotton cloth, and we're going to pause for a minute. Okay, so I want to refer back to your paper. You made a prediction. So think about, was your prediction, did it come out or not? If it did, great. If it didn't, that's okay. That's why we did the investigation, to actually find out for sure, because we wanted it to be based on something that is true, that we could prove. So we can see that the paper, 1 milliliter, you can fill this information in. The foil, 0 milliliters. The cotton cloth, 20 milliliters. And the paper towel, 13 milliliters. Boys and girls, another way to show that a little bit more detailed is by using a graph. So this starts at 0 and it goes up to 50 because we started with 50 milliliters of water. So we show that the paper, it absorbed 1 milliliter, the foil 0, so that's why you see no marks above the foil, the cotton cloth 20 milliliters, and the paper towel 13 milliliters. So this can show you how absorbent am I. So if you're looking for material that's going to absorb, say you spill your milk or you spill your juice, you might want to use a cotton cloth or paper towel. You would not want to use paper or foil. Okay, boys and girls, again, talking about property of matter and absorbency, things that absorb. Materials absorbency is a way that we can describe matter. All right, so after this lesson, you're going to go and you're going to look at for your homework, which is due on May 31st by 12 o'clock. And you're also going to, there's going to be a little video that you're going to look at. Before we end, I do want to mention one thing. We'll go back to the sponge and say, well, what makes materials absorbent? Why would some materials be absorbent and others aren't? Boys and girls, if you look at the sponge, you can see there's little spaces, right? There's little spaces that water can get into, and that's going to increase the ability for that material to be absorbent. If you notice that the foil, there's really no spaces. It's kind of flat and smooth. The sponge, it's soft, but it's a little bit. It has like little pits in it, little holes in it. So the water's going to cling in there, and it's going to absorb. Okay, I hope you learned a little bit more about properties of matter, and I will see you next time. I'll see you on Thursday. Bye-bye. Have a great day.